All right, so number one, it's a division problem. So what do we do before we do anything on division problems? Keep it, change it, flip it. So 2x to the third over 5. Change it to a multiplication problem. 7 over 4. And then do we see any tops and bottoms that could cancel? 2 and the 4, right? So 2 goes into 2 one time. 2 goes into 4 two times. Are there any other tops and bottoms? Nope. So we multiply straight across. So I have 1x to the third being multiplied by 7. 7x to the third. And I have 5 times 2. 10. Done. Yep. On number 2, it's multiplication, so it's already written in the order it should be written. Let's look at number 4. Do you guys see any tops and bottoms? Yeah, so 5 over 10 can simplify to what? Yeah, so 5 goes into 5 once, 5 goes into 10 twice. Anything else we can reduce? Nope. So we'll multiply straight across. 5 times 1 is 5. 4x squared times 2, 8x squared. Okay. What do we do first thing on number 5? You like it factored, remember? Because that was always like the thing we had to do before we cancel. So this problem is nice because they factored it for us, but it's a division. It's a division, so before we do anything else, we keep change flip. So 9 over 2 times v minus 6 times v minus 9 over 6 minus v minus 9. And there's something weird about the problem. Oh, I wrote it exactly the same. Sorry, my Okay, anyone see what's weird about it? Yeah, we have a 6 minus v right here. Okay, so I'm going to do this part off to the side. 6 minus v is written in the wrong order. What should it have been? It should have been negative v plus 6. And then when you have a negative in the front, what do you need to do? Take out the negative. And what would that give you? V minus 6. Okay, so what I'm going to do is I'm going to go over here and I'm going to erase this factor because it was written in the wrong order. And we just fixed it to negative of v minus 6. Okay, do you see any tops and bottoms that are identical? The v minus 6 and the v minus 9. And so you're left with 9 times a negative, negative 9. And on the bottom, you're just left with a 2. Because it's only on the top. You could say negative and then 9 over 2, like that. So if you have a negative in a fraction and there's only one of them, it doesn't matter if it's on the top or the bottom, it just matters that it's there. Okay, let's look at number 8. It's a multiplication problem, so it's in the right order. This says n plus 9 squared, so I'm going to go ahead and scribble out the squared. I'm just going to write it twice because that's what n plus 9 squared means. And then what do you guys see? So n plus 9, n plus 9, n plus 9, n plus 9. Mm-hmm. You feel like you got it? Okay, let's look at number 10. It's a division problem. So we got to flip the second one. So I have 8 minus x squared minus 6x minus 16 times x plus 8 over 1. And the 8 minus x is weird. What should I do? Not minus 8, plus 8. So negative x plus 8. So if you guys can think about this compared to what we were just doing with the simplifying fractions, it's basically the same thing. You just have two fractions now instead of one. But you're still factoring, you're still canceling.
And do we put the negative on the outside?
Mm-hmm. Yep. So for the top, we're going to take out a negative. That's going to leave us with x minus 8. On the bottom, we're looking for two things that multiply to negative 16 but add to negative 6. Negative 8 and 2. X minus 8, x plus 2. The x minus 8 and x minus 8 cancel. So we have the negative. But what about over here?
Negative x plus 8 over x plus 2.
So we keep the negative, we keep the top parentheses, we keep the bottom. If you want to distribute the negative 1, you can. You don't have to. So that's a good answer, or you could say negative x minus 8 over x plus 2. That's another good answer. Yeah. We canceled out the x minus 8s, but there was still this one over here from the second fraction. All right, so go ahead and start working on that. The answers are on the board already. So have you guys found any problems that you've been struggling with? Anybody found any problems you've been struggling with? So what problem should we do? What should we do? What number should we do?
No, as we're starting again.
Yeah, because I'm just talking about dates.
All right, so if you look at 15, do we need to keep it, change it, flip it? No. Is anything in the wrong order? No. So that means it's ready to start factoring. So how do we factor the top of the first fraction? GCF of 9n squared. So if you take out a 9n squared, what's left over? 72 divided by 9? 8. All right. On the bottom, we are looking for two things that multiply to be negative 56, but add to be 1. 8 and negative 7, so we have n plus 8, n minus 7. Over here, we're looking for two things that multiply to be 72, but add to be 17, 8 and 9. And then the bottom doesn't have to be factored at all, it's just there. All right, so what do we see? N plus 8, n minus 8. Anything else? Nope. So we have 9n squared, n plus 9, over n minus 7. Is there another problem we should do? Yeah. So 11 is a division problem, so what does that mean? Keep it, change it, flip it before you do anything else. And then what type of factoring is number 11? They're all in the correct order. We don't have to take out a -1 anywhere. What type of factoring do we do? It's not diamond, it's not slide divide, it's GCF. So you'll notice GCF factoring is very common. On these worksheets, lots and lots and lots of GCF factoring. So n minus 1 is factored already, that's just like by itself. What's the GCF for the bottom? 4. And then what does that leave you with? Okay. And then what's the GCF over here for the top? Okay. And then what do we see? They do, yep. 5 on top and bottom, those cancel. Cancel, cancel. And we get n minus 1 over 4. We're done. Is there another one we could do? On the second page, is there one that looks intimidating? Well, which one are you least excited for? 20? 27? I'm gonna do 27. So what type of problem is 27? Keep, change, flip, it's division. So 7m minus 7, 3m squared plus 15m plus 12 times 3m squared minus 18m minus 21 over 14m squared minus 14m. So now we got lots of factoring to do. Every single one of these has a GCF, all 4 of them. So for this one, when we take out the GCF, what's left over? Minus 1. What's the GCF on the bottom? 3. So that leaves us with m squared plus 5m plus 4. Okay, so that one's going to need a little bit more factoring, right? Okay. What's the GCF on the top? 3 or 3m? Just 3. M squared. Okay. On the bottom, what's the GCF? 14m, and then okay. So the top of this one is completely factored. For the bottom, we're looking for 2 things that multiply to 4, but add to 5. 4 and 1. So took out the 3. For the top, we're looking for two things that multiply to -7, but add to -6. Multiply to -7, but add to -6. -7 and 1. Okay, so what do we see? M plus 1, M minus 1, the 3's, the 7 and the 14. Yep, because 7 over 14 is 1/2. So 7 goes into 7 once, 7 goes into 14 twice. The M just stays there. Doesn't go away, it stays. All right, so what's left over on the top? M minus 7. What's left over on the bottom? And a 2 and an M.